Hello, Bobcats. Mrs. Woolhide here. We're finishing up Chapter 8, Lesson 8 today. It is a 5th grade standard, something you have to learn in 5th grade. I'm hoping that at the end of the lesson today, you'll be able to use equivalents to write fractions and decimals that are equal. Why, Mrs. Woolhide? What's the main idea? Well, it's important for you to see that the value of two different numbers can be equal, or two different things can be equal. When you think about a quarter, it looks very different than 25 pennies, yet they have the same value. They're worth the same. And today you're going to be looking at decimals that look so different than a fraction. And we're going to prove, or I'm going to show you that they have the same value. Well, what do you already know about place value? Well, if we look at what I wrote, 53 cents or 53 hundredths, we know that this 5 is in the tenths place. And we also know that this 3 is in the hundredths place. And they're on the right side of the decimal, showing that it's smaller than $1. The 5 is in the tenths place, or 5 out of 10, right? Or 5 dimes out of 10 dimes. Or you can see the 3 would be 3 pennies, or 3 cents out of 100. So you can begin to understand that place value and fractions are related. So from my experience, I know that anything on the right side of the decimal is smaller than 1. Tenths, hundredths are less than $1. The first thing we're going to do today is we're going to write a fraction, and we're going to make that fraction have a denominator of 10, 100, or 1,000. Once we get that denominator to equal 10, 100, or 1,000, we can create an equivalent decimal using that place value, right? Tenths, hundredths, thousandths. Once we have that fraction with that denominator, it'll be much easier to create a decimal that's equal. Finally, is it reasonable? Does it make sense where you put your numbers? Do they allow the two values to have the same worth? So 1, make that fraction with 10, 100, or 1,000 on the bottom. 2, go ahead and create a decimal. And finally, is it reasonable? Example 1. The average weight of a tennis racket is 2/5 of a pound. Write the weight as a decimal. Well, step 1 is to create that fraction so that you have 10, 100, or 1,000. Well, you can change 5 to 10 by multiplying by 2. 5 times 2 equals 10. 2 times 2 equals 4. So now I have 4 tenths, which is equal the same value as 2/5. Why did I change it? Why did I do step 1? Well, I'm looking for that denominator to be 10, 100, or 1,000. Now that I know it's 4 tenths, I can go ahead and put the 4 in the tenths place. So it is read as 4 tenths. Don't forget that THS. The average weight of a tennis racket is 4 tenths of a pound. It's reasonable because the 4 is in the tenths place, just like the fraction is 4 out of 10. All right, independent practice. Write each fraction as a decimal. Remember, we're trying to do step 1. Can we make the fraction have 10, 100, or 1,000 as the denominator? Let's look at problem number 4. Well, 20 is not one of those 3, so I'm going to change 20 to 100 through multiplication. And I know that 20 times 5 equals 100. 1 times 5 is 5. So 5 100ths is the same as 1/20th. I can now do step 2, create a decimal. Tenths, hundredths, thousandths. I'm going to put that 5 in the hundredths place. That's why I did step 1. So put the 5 in the hundredths place. And now I can put a 0 as a placeholder. So 5 hundredths is the same as 5 over 100 as a fraction. It's reasonable. Moving on to problem number 6. I'm going to change 25 to 100. I need to have 10, 100, or 1,000. 25 times 4, and now I can do 4 times 4. Well, I know 4 times 4 is 16. 16 hundredths has the same value as 4 25ths. I did step 1 so that I can get 100 as a denominator. I can now put 16 in the hundredths place as a decimal. Step 2. Tenths, hundredths. 16 hundredths is the same value. It's worth the same amount as 16 over 100 or 4 25ths. All three of them are the same, even though they look different. All right, Bobcats, 1/4. Can I make 4 turn into 10, 100, or 1,000? I'm going to go ahead and stick with 100. 4 times 25 is equal to 100. What is 1 times 25? Well, that's 25. So 25 hundredths is the same value as 1/4. Step 2, create a decimal. I need to make sure that 25 is in the hundredths place. Tenths, hundredths, thousandths. 25 hundredths has the same worth, the same value as 1/4, 25 over 100, or 25 hundredths. Moving on to problem number 13. Oh, it already has a 10. So all I need to do is put the 9 in the tenths place. I can skip step 1. They did it for us. Tenths, hundredths, thousandths. I need to make sure 9/10ths is in the tenths place. So 9/10ths has the same value as 9 over 10, or 9 out of 10. It's reasonable. Moving into problem solving. The smallest known female spider is 20/30 out of 50 millimeters long. The smallest male spider is 37 hundredths of a millimeter long. Write each fraction as a decimal. Well, I need to make sure these fractions have 10, 100, or 1,000. Well, it looks like the male spider already has 100 as the denominator. So I just need to make sure that 37 is in the tenths, hundredths place. So I know that 37 out of 100 is the same value as 37 hundredths. Let's move on to the female spider. I need to make that fraction have 10, 100, or 1,000. I'm going to change it to 100 because I know 50 times 2 is 100. So I just need to figure out what is 23 times 2, or what is 23 if we double it. Well, that's 46. So 46 hundredths has the same value as 23 fiftieths. Can I now make it a decimal? Absolutely. 46 hundredths is the size of the female spider. It looks like the female spider is larger than the male spider. It's reasonable because I created an equivalent decimal. Evan drank 2/25ths of a gallon of water throughout the day. Write 2/25ths as a decimal. Well, step 1, let's make that denominator 100 by multiplying. Well, 24 times 4 is 100. 2 times 4 is 8. Now I can make sure that 8 goes in the hundredths place. Tenths, hundredths. So I'm going to put my 8 in the hundredths place. Put a 0 as a placeholder in the tenths. 2/25ths is equivalent to 8 over 100, or 8 hundredths. It's reasonable because they have the same worth, the same value. All right, Bobcats, what did you learn today? Well, in summary, today I learned that if you can create a fraction with 10, 100, or 1,000, it's pretty quick to create it as an equivalent decimal. I also learned that decimals and fractions can be equal. They can have the same worth, the same value. Even though they look nothing alike, they can be the same amount. So thank you so much for your attention, Bobcats. Have a wonderful day.